A 55 kilogram shopping cart travels at 3 meters per second to the left. A 19 kilogram child, moving 5 meters per second to the right, jumps onto the end of the cart. Find the final velocity of the cart-child system. Whenever we have objects moving in opposite directions, we always have to define a direction that's positive and which direction is negative. And this is because momentum is a vector. Vectors could be positive, they could be negative, and here we have the child running in the opposite direction from the cart. So we have to choose a direction to be positive, and we have to abide by that decision. On the left is what we have initially, and on the right, this is what we have at the end. And the momentum of that initial set of affairs is the mass of the child, which is 19, times 5, which is his velocity, and that 5 meters per second is in the positive direction. The cart has a mass of 55 kilograms. This must be a rather full shopping cart, but it's moving at 3 meters per second in the negative direction. So notice I've taken those signs into account. At the end, the child and the cart are stuck together, so the combined mass is 74, and they are moving with a common velocity. And according to the law of conservation of momentum, the initial and the final momentum should be equal. If we solve that for v final, we get this number, negative 0.95 meters per second, which means who won this little collision? Well, it looks like the cart won this collision because the child and the cart are now moving to the left, that is the negative direction, at 0.95 meters per second. Why does it hurt more when the paintballs don't break? Maybe physics and the conservation of momentum can give us a glimpse as to the answer. Here we have an incoming paintball, and on the right we have you. This paintball has a certain mass and a certain speed, so it has a certain momentum. You are at rest, so you don't have any momentum. So initially, the paintball U system has an amount of momentum that is contributed only by the paintball. And I'm going to use a number. I'm going to say that the paintball contributes 2 units of momentum, and initially you have 0, so the total is 2. Now, the paintball breaks on you. The paintball now has no momentum because it has come to rest, which means that if we started with 2 and the paintball now has none, then you must have taken on 2 units of momentum because momentum is conserved. What about when the paintball doesn't break? We're going to start with the same situation. There's you on the right. Initially, you are at rest. So you have 0 momentum. You are about to get hit by this paintball that has a known mass and a certain velocity. And again, I'm just going to come up with a number just so we can get our minds around it. 2 units of momentum. So initially we have a total of 2. The paintball has 2, you have none, so the total is 2. Now this paintball hits you, but it doesn't break, it bounces off. And you can see by the picture that when the paintball bounces off, it's moving, in this case, to the left. Well, if moving to the right is positive 2 units of momentum, then moving to the left must be a negative momentum. And I'm just going to make up a number. I'm going to say it's negative 1. Remember that before the paintball hit you, the total momentum of the paintball U system was 2. The paintball had 2, you had none. After this paintball bounces off, the total momentum of the system must still add up to 2, which means you must have taken care of 3. And 3 units of momentum hurts more than 2 units of momentum. This is why it hurts more when paintballs don't break.